In the world of AI, you hear this claim all the time, and it's always said with this unshakable confidence. Sounds impressive, right? It makes you think we've hit some new peak of machine intelligence. But hold on, that statement should immediately trigger a question in your mind. Because that's really what a benchmark is. It's an exam. And, there is a massive, massive difference between just acing a standardized test and actually being able to perform under the chaotic, unpredictable pressure of the real world. So for the next few minutes, we are going to dive deep and peel back the layers of AI evaluation. We're going to explore why those incredible scores you see on all the leaderboards, why they so often fail to translate into a better, more reliable experience for you. Here's the game plan. We'll start with what these tests actually measure and, how they get gamed. Then we'll look at the illusion of progress this whole system creates and why that leads to spectacular failures in the wild. And to wrap up, we'll talk about a much smarter way to judge AI, one that relies on judgment, not just the numbers. So to really get a handle on this leaderboard illusion, we first have to understand what these so-called exams are even testing. So, what exactly is an AI benchmark? Okay, at its heart, a benchmark is basically a standardized test. Think of it like the SATs for AI. Big organizations like ML Commons, they define them with three key parts: a fixed data set, a specific kind of model, and really strict rules for how you evaluate it. And this is all to make sure it's a level playing field. Now, I want you to really focus on that one word, fixed. That single word is the source of a benchmark's greatest strength, and you guessed it, its biggest weakness. The strength is that you can reproduce the test over and over. But the weakness? Well, reality is anything but fixed. Right, because the test is totally frozen in time. It just can't adapt. It has no idea how real users are changing their behavior. It doesn't account for attackers who are actively trying to break the system. And it certainly doesn't reflect the messy, constantly shifting goals of the real world. A benchmark is static. They give you one picture from one angle at one single moment. They are not a continuous video feed of how a system actually behaves under pressure. And because the test questions are often public, or at least pretty well understood, an entirely predictable cycle starts to kick in. And this brings us to our next big point. When everybody knows exactly what's on the final exam, the goal changes. It stops being about learning the subject and becomes all about, just passing the test. In AI, we call this optimization, or to be a little more blunt, we call it gaming the benchmark. And it pretty much always happens like this. A benchmark, let's take MMLU, which tests the model's general knowledge, it becomes the gold standard. Pretty soon, developers are tweaking their training data so it looks and feels a lot like the MMLU questions. Then, over time, the actual test questions just leak into the giant data sets these models are trained on. This is what's called data contamination. And what happens? Scores shoot through the roof. But the model hasn't actually gotten smarter in a general way. It just got really, really good at this one specific test. So this is the key takeaway, right? The model is being fine-tuned for a very specific set of questions. It's not developing genuine, flexible intelligence. Okay, but if we know this is happening, why do we still get so hyped up about new high scores? Well, the answer is actually pretty simple. It's because the progress looks so clean, so undeniable. I mean, the numbers just keep going up and to the right. And this chart, this tells a story we all desperately want to believe. Model A scored here, Model B is better, and look, Model C is even better than that. It's such a simple, compelling story of progress. But this clean chart is hiding a very, very messy reality. Because out here in the real world, these models still fail on weird edge cases. They still have major safety gaps, and that gut feeling of, I can't quite trust this thing, that doesn't go away. So why is that? It's because a high score on a multiple choice test tells you absolutely nothing about how the model behaves on a slightly different problem. This gets into something called the accuracy paradox. Look at this. Imagine a spam filter that has 99% accuracy. Sounds amazing, but what if I told you it catches 0% of actual spam? How's that possible? Well, if 99% of the emails in its test data aren't spam to begin with, the model can just classify every single email as not spam and get a near-perfect score. It's a fantastic score for a completely useless model. This is exactly what happens when you just optimize for a simple number without understanding the context. And this problem absolutely explodes when these models get deployed out into the wild. See, benchmarks are run in these sterile, lab-like conditions. They're built on the assumption of clean inputs and users who are playing nice. But the real world, what developers call production, it's the complete opposite. It's a chaotic, unpredictable, and often adversarial place. A benchmark expects clean, perfectly phrased questions. Reality throws messy, typo-filled, ambiguous stuff at it. A benchmark assumes a cooperative user who just wants the right answer. Reality includes people who are actively trying to trick it or break it. And a benchmark usually measures just one thing, like accuracy, while real-world success demands a delicate balance of accuracy and safety and fairness and so much more. And this is just a perfect example of that disconnect. In the Helm project at Stanford, researchers found that some models would refuse to answer sensitive medical questions. Why? Because they were tuned for safety. And that is good behavior. You absolutely do not want an AI giving out potentially dangerous medical advice. But the benchmark, which was only looking for the correct medical answer, it marked that refusal as a failure. The model's score literally went down for doing the right thing. So how are we supposed to think about all this? Well, we need a new mental model. We have to stop treating these benchmark scores as the final, absolute verdict on a model's intelligence. Their job is to provide evidence. They offer clues and signals about what a model can do under very specific, controlled conditions. They get to testify, sure, but they do not get to deliver the final ruling. That job, that requires human judgment, your judgment. So the next time you see a headline screaming about a new state-of-the-art model, don't just ask, what was the score? Instead, I want you to ask these 3 questions. First, what behavior is this test actually rewarding? Is it memory? Is it creativity? Is it caution or speed? Second, what is this test completely blind to? Does it measure fairness or bias or how it holds up under attack? And third, what does this score really tell me about how it's going to act when things get weird, when a user asks something it was never, ever designed to handle? Because in the end, metrics are necessary tools. We need them, but they are not sufficient. They give us the data points, but it's up to us to connect those dots with context, with experience, and with some good old-fashioned critical thinking. You know, true intelligence isn't about passing the exam. It's about what happens after the exam is over, when the world stops being a neat little multiple-choice question and starts demanding creativity, resilience, and sound judgment. That is the real test.